TLS great again.
Afternoon, guys. Thanks for coming. So, first of all, not a cryptographer. The only relevant qualifications I have here into maths and reading Matthew Green's tweets. Like many of my talks, this is hopefully going to be a semi-educational rant about the future of TLS. It follows on quite nicely from Graham's talk earlier, so if you saw that, this is sort of the perfect companion. We're going to look at basically the future of TLS in the next sort of year. So the work that Chrome and Mozilla are doing in terms of deprecating HTTP, the highly impressive research that Chrome's usable security team have done in terms of changing the user interface. We'll have a little look at TLS 1.3 and some of the stuff that the CA Browser Forum are having a look at going ahead in terms of limiting cert expiry time and all that sort of thing. So yeah. HTTP is pretty much dead for... Can you hear me now? Oh, sweet. Yeah, so HTTP is dead by and large. Google have announced plans to eventually mark all pages that are HTTP as non-secure. Mozilla have rolled this out. Apple on iOS are enforcing app transport security, which we'll have a look at. So theoretically, HTTP is now widely regarded as insecure. So it should die off, right? Not quite as quickly as we'd like, right? If you're Google, you're doing pretty well. Across the entire Google estate, 85% of all requests they see are now HTTPS. 100% of Gmail traffic is HTTPS. You cannot access Gmail across HTTP. YouTube is at 98%, and their ad networks are at 88%. Calendar is in the high 90s as well, right? So they're doing pretty well. So just ignore this. The current now is Chrome 56. So if you're running Chrome at the moment, you're running Chrome 56. So this is essentially what the UI used to look like. You would just get this little eye here. There was no indication about the lack of HTTPS. Now, if you go to an HTTP page that asks for a password or credit card, and it's not got HTTP, you will see this, right? It's now marked as not secure. Firefox have got similar plans to follow through with this as well. So this is live in Chrome now. Firefox, they were supposed to go live at the end of January, but I think they ran into some edge cases with the warnings they were displaying on the actual input boxes that prevented this, right? And then the eventual plan for all HTTP pages in Chrome is that you'll be shown this very large, very scary, not secure dialog, right, in the URL bar. So this, by and large, is pretty good, right? HTTP should be considered harmful. Having said that, not secure versus secure in a browser to the standard person is very confusing, right? The work that we do with the Scottish Business Resilience Centre, we spend a good 5 minutes explaining to people what a certificate means and what the presence of a green padlock means. And we could speak to people about this for like half an hour, and they would still look at me in total disbelief, right? So this is by no means a solved problem. You know, the Chrome usable security team, Emily Stark, Adrienne Porter-Felt, you know, they've done some excellent research in getting us to where we are at the moment, but there's definitely a lot more to be done. So this is Mozilla. So I think if the Chrome one is from September of 2016, Mozilla were the cool guys. They did this first way back in April of 2015, and they are pretty much following the same kind of style as Google here, right? You will get this warning in the URL bar, and a little bit more helpfully, you will actually get contextualized warnings. So Chrome as well are going to offer these types of contextualized warnings, but it's going to be a gradual rollout. They're really quite invested in not scaring the shit out of the general public in terms of marking the whole internet as insecure and super scary. So this is going to be gradual. So one of the things that they're doing as part of this, for example, is that this, so, nope, back. It's the first time I've used this clicker, I swear. So this, for example, will appear in incognito mode first. The rationale being that when you're in private browsing, you have a higher expectation of privacy, therefore HTTP is considered extra harmful versus HTTP, right? So that's the sort of rollout they're looking at. And then Apple as well, so requiring apps to use secure network connections over HTTPS. They introduced this in iOS 9 called App Transport Security, which is just a fancy Apple marketing term for saying turn on the HTTPS. Their hard deadline for the requirement of App Transport Security was the end of 2016, but cryptography is hard. The hard deadline now is unannounced at some point in 2017. But the likelihood is by the end of the year you won't be able to submit an app to the App Store or have an update approved if you're using HTTP, which is excellent. So perhaps the biggest thing that will happen this year, or has happened this year, is the deployment of TLS 1.3. TLS 1.3 really is quite a special beast when you look at the other versions of TLS that we've had. This quote here, and I should say before we get into this, I shamelessly pillaged the living daylights out of the Cloudflare blog for all these graphics. So Cloudflare's graphic designer, thank you very much, and Filippo Valsorda and Nick Sullivan of Cloudflare. Their talk on TLS 1.3 from CCC this year is excellent, and they are far more intelligent than I am, so I highly recommend that to solve all the problems I'm probably about to confuse you with. But this quote here from Filippo Valsorda, it pretty much sums up the standardization process for TLS up until now. So Heartbleed is a perfect example of this. The Heartbeat extension came along. It seemed, this seems logical. The reason for it is sound. Let's just bang that in there. And then, like a year later, we're just leaking private keys all over the place, right? So with TLS 1.3, they really looked to consolidate and amalgamate things and fundamentally make it much easier for end users. One of the other big crypto arguments that we're having in the community at the moment is about cryptographic agility and whether we should offer multiple cipher suites and give a choice to the user, or if we should just declare ourselves superior as cryptographers and tell them what to use and don't let them use anything else, right? So I'm not going to get into the nitty-gritty details of what's changed here. There is a lovely GitHub page with a specification. We're on draft 18, which is in its final call, so we expect TLS 1.3 to be sort of approved and finalized by hopefully the end of March. The timeline was February, but crypto is hard. People are busy, especially the Cloudflare guys this weekend, right? That's a bad time. But so on the left you have TLS 1.2, full handshake, TLS 1.3 on the right, and straight off the bat you can see we've shaved like 100 milliseconds off it, right? The first connection from the client now has this key share, so we're really just optimizing, right? We're cutting down a lot of extra round trips, and this is excellent because now that we're pushing everything onto HTTPS, we introduced like an extra, 2 to 3 round trips per connection, depending on what you're doing. So this is excellent. And there's also 0 round trip time resumption as well, which basically negates the overhead for TLS, which I'm not going to go into, but the 0 round trip time resumption is some very cool cryptography. So we removed quite a lot of cruft, right? As Graham said, there's been a lot of bugs in SSL stacks, and just the SSL protocol in the last sort of 5-6 years. We were talking about this in the pub earlier, the union earlier, sorry. And it's kind of interesting when you look at the timeline of TLS, right? Because no one really cared, and then, the OpenSSL bugs came around, and now it seems like we're kind of hitting the point of maturity, or at least adolescence for TLS and SSL, right? In that we kind of had about a decade where no one really gave a shit, and now we're kind of starting to give a shit again because of various things that are happening politically and technically, right? So the first thing we got rid of was this godforsaken RSA handshake. So to be clear, RSA is completely fine. We still struggle to factor big integers, but the RSA key exchange is not good. We do not like it purely because it does not offer forward secrecy. So with a static RSA handshake, your server private key is what is protecting all of the connections, right? So the classic example of that is the LavaBit guys. FBI subpoenaed them for the private key, Once they got hold of the private key, they're able to decrypt any and all connections that they'd collected, right? Any connections to that server that the FBI had souped up, they could then decrypt them. So we phased this out for Diffie-Hellman ephemeral, or elliptic curve Diffie-Hellman ephemeral. Basically, the only change is that we still have our server private key, but for every session, we generate a new session key based off of that private key. So if you compromise the server's private key, you cannot then decrypt any of the sessions, right? And this is, in the sort of age of national security letters and nation-state adversaries, this is the sort of thing that we really want, right? Plus, Diffie-Hellman's much better than RSA for performance and other reasons, right? Something else that Graham touched on as well is CBC, Macklin encrypt modes. They have been absolutely panned in the last sort of 10 years or so. Vodney, Lucky 13, the original Vodney papers from like the late 90s or like early 2000s, right? This is pretty old stuff. So we now only have a head, so authenticated encryption with associated data. There we go. So this does your authentication and your MAC all at once, right? So lovely construct. We killed off RC4, thank God. That's finally died a death. I think there are multiple now real-world breaks against that. Rather timely, SHA-1. So Google, if actually, I forgot I had other slides here. So we got rid of RSA, so this kind of annoyed a lot of people, right? Because if you're generating a new key for every session, it now makes TLS termination for like big companies super difficult, right? So Matthew Green had to explain that they could still use Diffie-Hellman with static parameters, right? So there was a little bit of like Twitter drama surrounding this, where people thought Matthew Green was just putting an IETF backdoor in there, but this is known about, right? And then SHA-1. So yesterday we got the first full SHA-1 collision from Google. It should be pointed out that even though Google gave us this break, we would be in a seriously bad position today if it wasn't for the work of Google's engineers like Ryan Sleevey and co, who have worked tirelessly for the last 5 years or so to get SHA-1 deprecated and to get rid of it, right? I mean, we'd really be in the kind of internet is on fire type territory today if it wasn't for their efforts in the last 5-6 years, right? There was supposed to be a slide there, but I forget what it is, so I'm just going to go back. We've totally done away with compression as well. We chucked that. When you're compressing and encrypting stuff, or encryption and compression does not always play well together, right? And we got rid of the renegotiation as well, and we changed how we do anti-downgrade. And this is actually kind of cool. So I don't know if Adam is still kicking about in here. Other Adam with a job, Adam. But sorry, that was not a dig, I swear. But this is how they do downgrade protection now in TLS 1.3, right? So it was understood that at some point TLS 1.2 is probably going to fall victim to some sort of catastrophic failure. So we need a way to operate TLS 1.2 alongside TLS 1.3 and not have 1.2 screw us when some vulnerability comes around. So what they came up with was hiding this downgrade signal, pretty similar to the CVSC that Graham was talking about, in the server random value. And basically, a 1.3 client will know to look for this. So if you attempt to downgrade, a client who's aware will look for this, and it essentially works the same way that Graham explained the CVSV earlier. They will spot this and just go, no thank you. Whereas a 1.2 client will not know to look for this. Oops. The 1.2 client will not know to look for this, and it will be okay. So if you go have a look at how they implemented that, there's really quite a clever way of doing this, or it's seemingly clever. This might not look so clever in a few years, right? The last thing is let's encrypt. So the barrier to SSL TLS has usually been you have to go buy a cert, and certs cost money, and people don't want to spend money on security because there's no tangible benefit unless you're like talk and you've already been screwed, right? But essentially you can get free certificates from these guys. The certificate lasts for 90 days and then you can automatically renew it. the whole thing is automated, and it's entirely free, and it's awesome. And, yes. So, the 90-day thing. We are trying to get our mail server at work upgraded to a Let's Encrypt certificate because the current one is SHA-1 and is now broken. The nice man informed us that 90 days is a ridiculously short time for a certificate. However, this, again, Ryan Sleevey of Google, Ballot 185, currently going through the CA browser forum, is looking to basically limit the period of validity. So subscriber certificates issued, certificates issued on or after 1st May 2017 must not have a validity period greater than 398 days. So the thinking here is essentially, if your TLS cert gets compromised, and at the moment, if you're trying to revoke a compromised TLS cert at the moment, it's a little bit of a shit show, to say the least, right? So the thinking here is that if you get your certificate compromised, it's then valid in the hands of an attacker for less time. And the other one here as well is that if we can have domain owners validate that they own that domain, a little bit more regularly, this is probably not bad for the web either. So Let's Encrypt is, they are a force to be reckoned with now. The researcher Scott Helm did some scanning of the Alexa million recently, and Let's Encrypt are now the dominant CA in the Alexa million, right? That's pretty impressive for a company that's only been around 18 months maybe, I think. And these are just some of their major sponsors. Gandhi.net, I think F5 and some other big VPN terminators are on there as well. So, go use them. And lastly, CertBot from the EF. So, I said it was free, I said it was automated. CertBot, built by the EFF in cooperation with Let's Encrypt, completely automates this process, with the caveat that you have to be on NIX. If you're on Windows, unfortunately, you're kind of screwed at the moment. You have to do it manually, but if you're on Unix, it completely automates this process. So, yeah, just in closing, these are some useful tools, but the main message really is deploy HTTPS in all the places. Google are now taking it into consideration for page ranking and things like this. And it's not just about whatever the user is sending to you, right? You're actively endangering your users by not enabling HTTPS because of things like, man on the side attacks. You can go look at all the scummy things that people like AT&T do in terms of injecting universal tracking cookies, and all this sort of nonsense, right? It has issues, but we're getting there. Please deploy it. Please encourage others to deploy it. It's free and awesome. And fuck Donald Trump. With that, I'm done. Oh, and if you'd like to discuss encryption, PKI, SSL, TLS, come find me. Probably get me before like 1, but yeah, come find me.